In this video, I will mainly introduce horizontal comparison for brands safety system: Siemens, AllenBradley, Omron, and Beckhoff. I will show what the hardware configuration and the software looks like from these four main brands. Generally speaking, Siemens and AllenBradley, they are the similar style. That's because the standard controller and the safety controller for the AllenBradley and the Siemens integrated together. For example, the AllenBradley safety CPU will labeled with ICE. The Siemens safety CPU will labeled with a F, functional safety. So the standard PLC and the safety logic, they all integrate together in this controller. So they're quite easy to exchange the signals between the safety and the standard. For the Beckhoff and Omron, their safety style and the software, they are quite similar. Standard PLC is a standard PLC. Safety controller is a safety controller. For the safety controller, it is a standalone module. If you need to exchange the signal between the safety logic and the standard logic, or reversely, you do need this buffer to exchange the signal between the safety and the standard. For example, you need to use that buffer, put the safety signal, transfer to that buffer, and after that, transfer the buffer signal to standard logic. Or reversely, if you need to transfer a signal from the standard PLC to the safety PLC, you need to transfer that standard type to that buffer, and after that, transfer that buffer signal to the safety logic. But it doesn't mean it's creates trouble for you. Actually, it can help you to isolate the standard logic and the safety logic. So next, I will one by one introduce those four main brands safety control systems. So the first safety control system I would like to introduce, that is the Siemens safety system. And currently the main programming environment for the Siemens, that is the TIA portal. So if you install the TIA portal to program the Siemens safety system, you need to guarantee in your TIA portal system you already installed the step 7 safety. And a typical Siemens project is like this. This is a PLC. The typical controller is called 1516F system. Usually for the robot cell, for the Siemens system, the common used module, that is the ET200SP safety input and output. For example, in this project, if we go to the device configuration, and this is the safety controller, for the Siemens safety controller, the standard and the safety portion, they combined together. So their controller will labeled yellow frame like this. That means that controller is a safety controller as well as the standard controller built together. This is the main CPU, and on the right side of CPU, there's no module. That's because this is a 1500 controller. If you are going to use the 1500 safety input and the safety output signal module, those modules are really expensive. So an alternative way, usually the industry distributor or industry integrator, they will use the ET200SP safety input and output. The typical style will be like this. That is the ET200SP remote station. That is an interface module, and this interface module has a 2 Profinet communication ports. It includes the standard input, output, as well as the safety input and output. It's quite flexible. You can configure based on the safety devices and the sensors allocation. The entire network looks like this. So the controller will communicate through the Profinet, the Ethernet cable, and communicate with the different station. And if this remote station has a safety function, so this station icon will show this yellow button here. That means this station has a safety module on that. With this configuration, your safety input and output can be totally distributed. And this combination could be very flexible. And if we go to this And if we go to this hardware configuration, we can see for the channel, totally this module has 8 channel here. But for the different application, for example, the channel 0 and 4, if I'm going to use the 1002 evaluation equivalent function, so this channel 0 and 4 will bundle together. For example, this channel 0 and 4 is connecting with one e-stop button, like shown in the screen. And the first 2 channels, 0 and 4, that's 2 channels are connecting with the e-stop button, because for the e-stop, to guarantee the CO3 level or the PLE level, the e-stop will use the 2 parallel loops like this. So from the hardware wheel, you need to configure this 1002 equivalent. Also, you can set this discrepancy time here. So that is the safety module under the remote station. If we go to the safety program under this controller, so firstly to configure this safety administration, you can go here and configure the basic configuration. And for the programming, those function and function block as well as DBs, they are under the standard PLC. For the safety logic, under the TI portal, all the safety function block, they are all marked with this yellow label here. So you can set up one folder here. This folder doesn't have any code relationship. It's just a folder. It's easy for you to organize the function and the function block as well as DBs. If we go to this function block 5, e-stops, it has all the e-stops function block here. For example, the e-stop switch, e-stop, and that is the output. And this e-stop input is already grouped by the hardware. So every time when you program the e-stop, you just need to use the lower address. For example, if we use the 5000.0 and 5000.2, these 2 channels, you only need to use the 0.0. For example, this channel 6002, so that is the hardware we just shown. So for that e-stop, that 2 channels already grouped it by the hardware configuration. So when you program this e-stop channel, you just need to use this lower address, that is 0. So this function block output, that represent the e-stop on this HMI2 panel. If we go cross-reference, we can see from here it grouped it. So from here we can see this global e-stop summation is grouped all the e-stop signals in this cell. So one of the buttons in this cell pressed, so the signal will drop. So this some e-stop signal will go from 1 to 0. Also in the TI portal safety logic, it's highly recommend you create 2 buffer DBs. One buffer DB is used to transfer the standard signal to the safety. One is used to transfer the safety signal to the standard, for example, showing the status on the HMI. Otherwise, if your safety logic use some tags from the standard PLC, rather than use the signals from this buffer, if those tags from the standard PLC got compiled or got changed, at that time, even if your safety logic haven't got any change, but your safety signature or the timestamp may get a change. It will ask you to compile, and after compile, your signature would have a change. So that is the Siemens TI portal hardware configuration and safety programming style. The next safety system I would like to introduce, that is a Rockwell AllenBradley Compactlogix control system. So in this project, that controller is a Compactlogix safety controller. It's similar like a Siemens control system. So this safety controller combines the standard controller and the safety controller. So the standard control logic and the safety control logic can be programmed inside this one controller. And this is the typical standard logic in this Studio 5000 programming environment. And all the safety logic are under this safety task here. So we can start from the hardware. In the hardware configuration, under here, usually the safety card will use those 1734 input and output card under the point IO remote station. And the remote station will communicate using the Ethernet IP, communicate with this Compactlogix controller. If we go to this input card, check out the properties of this input card, we go to the input configuration, similar like the Siemens we just introduced. For the safety control for the equivalent circuit, we will select this equivalent. And for the discrepancy time, we can set here. This is the hardware configuration portion. And if we go to the safety logic, this is the e-stop programming style. So instead of use this physical I/O, in the AllenBradley, they all use the tag name. Because of the tag name usually assigned by the system. So before we use this the tag, we will do a mapping. For example, for this map inputs, so we will map this the slot 5 input module to this main rack safety I/O inputs cards 5_5 to address this safety channel from this number 5 slots safety card. We will use this COP to copy this physical channel name main panel IO number 5 module to copy this tag name to this UDT structure, that is a main rack safety IO dot inputs dot card underscore 5. This name, you can create a name by you want. And when you use this channel, so for example, if you want to use this first channel of this module, so it will be the card underscore 5, the first one, gate e-stop, the channel A and B. So we can click this monitor to check out in this channels, what kind of channels and what the name we assigned here. That means when you name the channels, you must think carefully. Like this. So from this name, you basically know this channel comes from the main rack, and that is a one safety module, and that is a one input card, and this card's number comes from the 5 slots, and what the specific channel name. This name can align with your drawing. So that means when you name this channel, instead of using the physical channel, you need to think some deeply for your name, how to name your channel for this. And other than that, we can see all the safety logic and all the safety routine, it's labeled with this red sticker. That means those logics are the safety logic. And for the Ethernet safety control, usually if one device, for example the robot, need to communicate with this safety controller by using the Ethernet IP safety, so usually there will be a terminology named SNN. If we go to this CPU properties, under this CPU properties, here it named the safety network number, SNN number here. And if we go to this Ethernet IP safety EDS file, we double click this robot. Under this robot EDS file, it also has a one SNN number here. So when you configure the communication between the robot and with this Compactlogix controller, you need to assign this SNN number in your robot side. This is a little bit special under the Ethernet IP safety communication. That is the Studio 5000 AllenBradley safety control system. What the software and the program look like. Safety system I would like to introduce, that is a Beckhoff TwinCAT 3 platform TwinSAFE system. So the Beckhoff controller CX 5000, 2000, those controller will running as the standard PLC as well as the built-in PLC HMI. If you need to involve the safety control, so that safety controller is one standalone controller. That is the EL6900 or the 6910. That is a one standalone controller, but this controller can be mounted together with other terminals. It's quite similar with other terminals. For the safety input module, that is a EL1904, safety output, that is a EL2904, and this is the safety input module, and this is a safety output module. So the safety logic will be programmed inside this EL6900. So take this system configuration as an example. For the safety input 1904, if you want to look at the detailed configuration under this safety module, you will not find any information for that configuration here, because for this hardware configuration setting are imaged under this alias devices here. So if we double click this terminal 3 EL1904, so under this safety parameters, here we will check out the detailed configuration for this channel and for this module. For example, for the e-stop buttons or mechanical gate switches, they basically the joint contact circuit, so you could select the single logic channel. Or if you are using the output signal switching devices or SSD devices, for example, light curtains or the solid state gate switches, so especially they have its own test path, so you could select unsynchronized analysis or SSD. But keep in mind, if your safety devices has its own test path, keep in mind in your digital input devices, you need to set 8001 properties sensor test channel active to off to allow your devices supply its own test path. Let me use the joint contact e-stop button as an example. We go to this safety programming group, we double click. So that is the e-stop function block. And for this e-stop function block, to bundle the two channels together, we will give a two name of this two channel. And from here, you also enable the second channel. Change the import setting. And set the second channel to channel. The contact style, that is NC, break contact. Normal closed. And the discrepancy time can be set here. And how we can connect this the two tag name channel 1 and channel 2 to this physical channel. So under this programming environment, from here, variable mapping, so we can assign the physical channel to this tag name. This tag belongs to the safety controller, like this. So this channel 1, we assign the terminal 3, this module input, channel 1 input, and the channel 3 input. Bundle these two channels together. So this variable mapping plays very important role. It connects the safety tags to the physical channels or some tags from the standard PLC. So this channel 1 and channel 2, those tags belongs to the safety controller. To assign the physical channel to this tag, we will click this dot button here, assign the channel to this tag name. Like the setting in this project, this terminal 3 safety input has 4 channels. The channel 1 and the channel 3, those two inputs are assigned to this channel 1 and channel 2. And from this function block, bundle those two channels together, and that is the e-stop output. the safety tag name, channel 1, channel 2, reset, and e-stop, those names are used in the safety program, but the actual signal, we need to use this variable mapping to map the tag and the physical channel here. And if we need to exchange the signals between the safety and the standard PLC, we need to create a tag under this alias device. For example, we need to create this, add the new item. We need to create the digital input and the digital output to exchange the signal or data between the safety controller and the PLC controller. So that is the Beckhoff programming environment and safety controller style. The fourth safety control system I would like to introduce, that is the Omron NX safety control system. And this software platform, that is Sysmac Studio version 1.30. The typical Omron safety controller style, like shown in this screen, this is the standard PLC. And the safety controller, like this controller, NX SL5500, that is one standalone controller. It's quite similar like a Beckhoff. The typical safety module for the input, that is NX SID800, and for the safety output module, that is NX SOD400. Because this standard controller and the safety controller, they are separated. So when you program the safety logic, you need to shift to the safety CPU. By default, it will show the standard controller. So we need to shift to the safety CPU. And once we switch to the safety CPU, the CPU is labeled as a red. So all the safety module and the safety program we can see under this page. So if we need to configure the safety input, for example, for this safety input, we can double click this parameter. And from here, this is quite a nice design. So for this safety input, you can see the detail of each channel and each port, how we can wire and how we can assign for this safety input module. For example, for this e-stop button, for the two loops channel, the T0 and the T1, that is a signal come from the module. And the input signal, that is a SI00 and SI01, you can assign the name at here. Gate e-stop channel 1, gate e-stop channel B. Also, you can click this configuration button to configure the durable channel or the single channel. You need to drag the different tag here. So when you drag this tag, it will configure the single or durable channel for this input. Once you drag this tag, you can click this configuration, and from here you can assign that discrepancy time for this two bundled channel. That is the hardware configuration. For the detail and the setting over picture. So for the wiring, this picture shows very clear, especially for the on-site troubleshooting. Shift to the programming. The safety program, we can find the program under this POU programs here. Same style, if we go to the e-stops, under this Omron software, the safety logic language we can use, that is FBD. And this channel that connect with the physical channel here. And from here, we name this MCP e-stop channel A. So that is the safety tag name. That is the similar idea with the Beckhoff system channel 1 and channel 2, if you recall. So how we can connect this tag to that physical channel? We need to go to the IO map here. So we can see this NX as input 800, that is the first safety input module. And in this module, it has 8 channels here. And because the first 2 channels, we bundle them together, that is a durable channel. For each single channel in that configuration, I named the gate e-stop channel A and B. But from programming well, we only need to name the only one channel here. This name variable will be used for the programming. And because of the hardware configuration already bundled these 2 channels together, so when we program, we only need one channel name programmed in this safety logic. So using this tag, it addresses the physical channel on this physical card. That is a similar idea with the Beckhoff variable mapping list. So that is the Omron programming style. You can write the comments here, and you can summarize all the e-stop together like this way. One of the e-stop job, so the summary of the e-stop will job. Programming style, that is FBD. So that is the Omron safety controller programming and the hardware configuration rough idea. To do a quick summary, in this video, we basically introduce the 4 main brands: Siemens, AllenBradley, Beckhoff, Omron, their main controller and main programming environment, what the hardware configuration and what the programming style looks like. Hopefully, this video could give you a rough idea of this 4 main brands safety system.
Thank you for watching. If you like this video, please give me a thumb up. If you'd like to watch more videos in my channel, please subscribe. See you in next video.